Alright, section 6.5 talks about exponential and logarithmic models. All what you need to do out of this is look at a problem and think, if it's a log, I know how to solve that. If it's an exponential, I know how to solve that. Fill in the blanks. I know work problems are not very pleasant to students, but not this section. This is a special case. So if I'm looking at this equation, I notice there's a natural log in there. There's two variables, n and p. I need to know what n stands for. The mathematical modeling for learning an assembly line procedure needed for assembling one component of a manufactured item is given by, and here it is. N is the practice sessions. P is the proportion of correctly assembling components. So the more they practice, the more they do. Well, let's see how this works. What is it they want? Either they want P or they want N, one of the two. So if I read the problem, in terms of number of practice sessions, okay, use the model to predict the percentage. P is the percentage. They're looking for P. What does P equal? To the nearest tenth of a percent. Okay, no big deal. That will correctly be correctly assembled out of 5 practices, n equal 5. Well, if I take this equation and I let n equal 5, what kind of an equation is that? That's a log equation. What do you do with equations? What do you do with any equation you solve in math? You isolate that name by itself. It's a log equation. You divide by a -5. And if I have a log equation and I can't solve, I'm going to make those powers, if you recall. So e to the -1 is going to be 0.94 divided by p minus 1. Remember that e is a number. I see a fraction. A couple of ways I could do this really. I could clear the fraction. The LCD is p multiplied by p top and bottom. Oops, not that one. And that will be p e to the -1 equals 0.94 minus p. Get all the p's on one side. And again, this was on exam 1. Factor a p out because that's common in both. There are other ways you could solve that. And p will equal 0.94 divided by e to the -1 plus 1. That's an exact answer. P equals, I'll get my calculator out, and I'll have 0.94 divided by e to the -1, there's e, raised to the -1 plus 1. I'm getting that to be, and I'm going to write this down and answer the question really quick. So what I'm getting is 0.68. So I'm going to say P is, and they want it to the nearest tenth of a percent. Tenth of a percent, that's 68.7%. So after 5 sessions, this new employee will be able to assemble 68.7% of the components. Next problem. Any problem that deals with population. Any problem. The book likes P equal P naught e to the RT. That's very close to A equal P e to the RT. Not very close, it's the same. Meaning what? This is the deposit in a bank. This is the initial population. This is the amount in a bank after a given time. This is the population after some time have passed. T is the number of years, and R is the rate of growth or decay. You want to use that, you can. I really don't mind. So P naught is the initial deposit, or in our case, population, any population problem. The number of bacteria in a sample is increasing according to an exponential model. There it is. Any population works, it grows according to a exponential model is modeled by this equation. So, what does it say? After 2 hours, the sample contained 200 bacteria. After 2 hours, this is time and this is speed. 2 hours, the sample contained 200 bacteria. After 6 hours, the sample contained 800 bacteria. Write an exponential model for the number of bacteria in the sample after X hours. They don't like T, they like X. So what? Here it is. Well, let's see how this works. What I need to know what the initial amount is, and I need to know the rate. So, given this information, this says 200 after 2 hours. And this says 800 6R. This is a system of equations. Now, the one thing I was hoping for, that we do this before the next chapter, but this problem is a loner. They really don't go into systems of equations because we're going to learn that in chapter 7. But for now, if I take the top equation, wouldn't you say the initial is 200 divided by e to the 2r? Take this and substitute it right there. Wouldn't that be 800 equal 200 over e to the 2r e to the 6r? And wouldn't you say this will yield 800 equal 200? Don't you subtract those because you're dividing? 6r minus 2r is 4r. This is an exponential equation. Isolate the exponential by itself. Divide by 200 both sides. That's 4 equal e to the 4r. And now what? Log both sides. What base should I use to eliminate that exponential? Natural log of 4 equal 4r. So r is natural log of 4 over 4. Got it. What's left? Now that I know this, let's plug that in there and figure out what the initial population is. The initial population is 200 over e to the 2 times natural log of 4 over 4. Well, let's get those two values, plug them in, and call it a day. This is going to be the initial amount right there marked in yellow, and this is going to be the interest rate. And if I get my calculator, I'll take parentheses, natural log of 4. Again, I'm doing this for you. My calculator could do this easily, but I just don't want you to do that and mess it up. I want to make sure that you learn how to do that in your calculator. It's a big number. You could leave it exact. You could write it out. I'm going to do both for you. So you have an option every time you do this. Darn thing doesn't want to move. Here we go. Okay, I love that. Here's what we get R to equal. So either we do that, or, and no big deal, let's do the bottom one. What's the initial population? If I take 200, I'll talk about that in a minute. 200 divided by parentheses and e, oops, wrong key, and e raised to the 2 times natural log of 4 divided by 4. So this is, either you say 100 e to the 0.34, at least, if you're going to write it, at least 5 decimals. 34657x, and that will be the actual equation. Or you would say P equal 100 P equal 100e, and you could write it as natural log of 4 over 4x. I really don't mind either way. Now you give me an x, I'll tell you what the population will be. You give me a population, I'll tell you how long will it take to get there. Same deal here. They talk about half-life, in case you've never came across that. Half-life, whatever you start with, you have half of it left. That's how long it takes to lose half of the amount you have. And they're giving me this equation. I'm going to stick with population. Find the half-life to the nearest tenth of a year of a radioactive substance that decays from. So initially, at time equals 0, it was 80 milligrams. To 25 years after, now it's 15 milligrams. Right? They tell you, explain all of that, what that means. Find hint. We don't need a hint. That's for the average student. We're not average. They said find the half-life. Well, this is what I need. I need to come up with the equation. I need to know that they use P equal P naught e to the RT. Again, A equal P e to the RT, no difference. What do you start with at time equals 0? 80. So P equal 80 e to the RT. The only thing left to find is R, and that's where this information comes in handy. And how is that? Well, let's see. In 25-year time, I'm going to have 15 left. What kind of an equation is that? That's an exponential equation. Well, isolate the exponential by itself. Divide by 80 both sides. Now what? Natural log of 15 over 80 equals 25R. So R is natural log of 15 over 80 divided by 25. Right? Now I'm going to show you how to do this on a calculator. Not the answer, that is. I'm going to show you how to use the calculation to work out the problem. So R is really a decimal, a big decimal if I'm going to carry it. So I'm going to take natural log of 15 divided by 80, all divided by 25. There's R. Any population problem, I would use that equation and that will work. I wouldn't use any equation they give me. You could use it if you want, but this is much easier than what they have. I think this is me though. So now we have a couple of options, and let's get that out of the way. We did all of that work. Now we say, okay, well, either you tell me that P is, we started with 80, e to the negative 0.066959 t or x, whatever you want to call it. Got it. Or you tell me P equal 80 e to the natural log of 15 over 80 divided by 25 t or x. Right? So how does that work? They want us to use y. I mean, you know, you could put y instead of p. If I look at this problem, what are they asking? They're saying find the half-life. If you start with 80, what's half of life? If you start with 80 milligrams, then isn't half 40? Find the half-life. How long does it take for that to happen? You could use this. There's nothing wrong with that. Or you could use this. Remember, this is still stored in my calculator as an answer because that's the last thing I calculated. So now what? Now you isolate the trig function by itself, divide by, that's times, right? Divide by 80 both sides. So 40 divided by 80 is 1/2. And what are we going to do now? We're going to transform this to log form. And if I divide by the negative 0.066959, how am I going to plug this in my calculator? I already know what's stored in my calculator. As I see, that denominator is my answer. So all what I have to do is take natural log of 1/2 divided by my answer. And it's going to take 10 point, what did they say, round to what? 10th of a year. 10.4 years. 10.4 years. In 10.4 years, this 80 milligrams will lose half of its value. And that's how we do any problem. If they didn't give us initial amount, we assume the initial amount is 100. 10 or 100. 100 is easier. Here's another problem. This problem is on investment. This says, so an investor wants to analyze the earning of a mutual fund account. Okay, doesn't know what that is. 4 years ago, so this is 4 years ago, this is now. 4 years ago, the value of the account was 16,000. And now, it is 24,000. No additional deposits were made. Okay. If the account is compared to a bank account paying interest compounded continuously, what interest rate, rounded to the nearest 100% would the bank account have to pay to match the mutual fund? Okay, well, how does that work? This is what matters. I started with 1600, right? In 4-year time, that amount became 24,000. That simple if you just get really comfortable with filling in the blanks. What kind of an equation is that? That's an exponential equation. Isolate the exponential by itself. E to the 4r equal, the zeros cancel out. You could reduce that, you could not reduce it since you're using a calculator. And wouldn't you say I'm going to log both sides? What base should I use to get rid of that exponential? E. So 4r will equal natural log of 24 divided by 16. And r will equal natural log of 24 divided by 16 all over 4. And r would be, and that's not the answer because I need to convert that to percentage. If I take natural log of 24 divided by 16 divided by 4. And if I pick that up, this is in decimal. I could say here that, you know what, R is 10 point, what did they want? 100, 10.14%. If this bank wants to match the mutual fund so that the investor will invest with them, they will have to match it with 10.4 interest, which is very unlikely. How about this problem? They're giving us a formula. We don't have to come up with one. That's good. In a small town with a population of 1720, the total number of people Y infected. Y is the people that are infected by a virus X days. X is the number. This author loves X instead of T and Y instead of P. No big deal. After it is introduced to the population. So this model tells you how many people will be infected by how many days. Sounds familiar nowadays? 12. Find the percent of the town's total population that will be infected after 4 days. What's that? Days would be X. So, Y would equal 1720 divided by 1 plus 550 E to the negative 0.88 times 4. That number of people infected will be, and how am I going to input that in my calculator? 1700. Oops, 1720. I already messed it up. Divided by parentheses 1 plus 550 times e raised to the negative 0.88 multiplied by 4 close parentheses equals 99.54%. 99 point, what did we say? 5%. Almost the entire population. You'll figure out it's very hard to get these things under control. And number 18, they say the growth of a city is described by a population model. We already know that. Where P0 is the initial amount, we know that. T is the number of years. K is like, okay, all of that stuff is awesome. At T equals 0, the population is 1500. That means automatically P equal 15,000 e to the kt. Got it. All what I need to find now is K, and I'm set. And the population of the city 3 years after is 19,000. So now, when 3 years have passed, this 15,000 became 19,000. Can I solve for K? Of course I can. Isolate the exponential by itself. 19 over 15 equal e to the 3k. Natural log of 19 over 15 equals 3k. And k would be natural log of 19 over 15 divided by 3. I have two options for k. I could plug things in my calculator, or I could leave it as is. I'm going to do both for you. 19 divided by 15 divided by 3. And it is there it is. I don't learn, huh? I should put this in first, then I should box it. Now, if I want to use this, I want it to be accurate, I have to take enough decimal places. So I have P equaling 15,000 e to the 0.078796 t. Okay, what do they want to know? What is the approximate population when t equals 6? Well, isn't P of 6 15,000 e to the 0.078796 times 6? And wouldn't the population be? And notice that this value is already stored on my answer. So all what I have to do is take 15,000 e raised to my answer multiplied by 6. And I'm getting a total of, to the nearest person, because this is population, 24,000. Where is it? 24,066.6666. So we say 24,067. We round to the nearest person. Oh, round to the nearest 100. Oh boy, that's new. We almost never do that. I've never seen that before. But it's all good. There's always a first time, right? If we're talking about population, normally we say people. We don't say half a person, or a quarter, or whatever. No big deal. This author likes that. Who am I to criticize? And there's your homework. And that takes care of this section.